Hello there, this is Miss Nakayama, and today's lesson is 10.2, Arithmetic Sequences. In this video, we are going to find the common difference for arithmetic sequences. We're going to write terms of an arithmetic sequence. We're going to use a formula to find the general terms. We're going to use a formula for the sum of terms, and then we're going to solve applications using arithmetic sequences. So, first, let's define what an arithmetic sequence is. Yes, it looks like arithmetic, but it's pronounced arithmetic because it's an adjective. An arithmetic sequence is a sequence in which each term after the first differs from its preceding term by a constant, and that constant is called the common difference. So, look at this example. Example 1, writing some terms. Write the first 6 terms of the arithmetic sequence in which a sub 1 equals 100 and a sub n equals a sub n minus 1 minus 30. So remember, this is just notation. That just means that it's the term that comes before this term. So we're going to go find, they tell us a sub 1 is 100. So that means the next one we're going to do is find a sub 2. And a sub 2 is going to be a sub 1 minus 30. And a sub 1 minus 30, of course, is 100 minus 30, which is 70. Then we go find a sub 3. And a sub 3 is going to be a sub 2 minus 30. A sub 2 is 70. Minus 30 is 40. A sub 4 is a sub 3 minus 30. A sub 3 was 40, and 40 minus 30 is 10. A sub 5 is a sub 4 minus 30, and a sub 4 was 10. 10 minus 30 is negative 20. And then a sub 6 is a sub 5 minus 30. A sub 5 was negative 20, and negative 20 minus 30 is negative 50. So our 6 terms are 100. Oh, wow, I forgot that one. 100. Let me add that because that's only 5 terms. So I'm sure you won't have any trouble filling that in on MyLab Math. But 100, 70, 40, 10, negative 20, and negative 50. Good move. All right, general term. The general term of an arithmetic sequence. That is referred to also as the nth term or general term. And if you know the first term, which is a sub 1, and the common difference, which is denoted with the letter D, then the formula for the general term is a sub 1 plus n minus 1 times D. And I will tell you that each time to write it, you're going to have to fill in a sub 1 and D. That's what makes one arithmetic sequence different from another one. So look at this one. This says use the formula for the general term of an arithmetic sequence. So they want us to find the 9th term of the arithmetic. Okay, I hadn't done that in a long time. Find the 9th term of the arithmetic sequence whose first term is 6 and whose common difference is negative 5. So keep in mind from that sentence, the 9th term is a sub 9. The first term, 6, is a sub 1, and the common difference, negative 5, represents D. So in our general formula, we have a sub n equals a sub 1 plus n minus 1 times D. Then I'm going to go fill in a sub n. A sub 1 in this case was 6, and D was negative 5, which you can simplify as if you want. Okay, you can go a step further and say, well, that's, of course, simplifies to 11 minus 5n, but you don't have to. A sub 9, but also keep in mind, before I go on, this right here is the formula for the general term. So if you're asked for the formula, then you stop right here. Our particular problem is asking us to find the 9th term. So I'm going to go from this formula. I didn't have to simplify it, but you can. I didn't. A sub 9 is going to be that formula, but this time I'm going to plug in 9 for n. And when you simplify that, you get a sub 9 is equal to negative 34. So that's our answer. Okay, we have another formula, the sum of the first n terms of an arithmetic sequence. The sum, denoted capital S with a subscript m, is given by this formula, okay, which A sub 1 is still the first term, but A sub n is the nth term or the last term. So we say n over 2 times the sum of the first and the last terms. So look at what we'll have to do. Example 3, find the sum of the first 15 terms of the arithmetic sequence. So if I want the sum of the first 15 terms, I'm going to start off with my sum formula. Okay, that was n over 2 times the a sub 1 plus a sub n. And now I'm going to go fill in. If I want the first 15 terms, I'm looking for s over 15. S sub 15. 15 is n. So that means I want n 15 over 2. A sub 1, clearly from what they gave us, is 3. But I don't know a sub n. So I'm going to have to come over here and find a sub n, which is a sub 15 in this case. And to do that, I'm going to go fill into my general formula, which is the first term plus n minus 1 times the common difference. So I go back to my numbers that they gave me, 3, 6, 9, 12, and what's the difference? Okay, y'all, you're always thinking of the difference like this. Okay, 6 minus 3, the difference between those two, and it doesn't matter which two you do. You can do 9 minus 6. You can do 12 minus 9, whichever is easiest for you. But it's always you take a term and you subtract the one that comes before it. Okay, another way to think of it is these numbers are getting bigger, and if they're getting bigger, D is going to be positive. If these numbers are getting smaller, then D is going to be negative, which is like the first example I did. So in this formula over here for a sub n, my D is 3. So a sub 15 is going to be 3 plus 15 minus 1 times 3. So a sub 15 is 45, and that's what I'm going to plug into my formula and find out that the sum of the first 15 terms is equal to 360. Okay, last example. Solving applications with arithmetic sequences. Number 4, example 4. A section in a stadium has 22 seats in the first row, 29 seats in the second row, increasing by 7 seats each row for a total of 45 rows. How many seats are in this section of the stadium? So I'm going to list out these numbers. I got 22 and then 29, so forth and so on. So 22 is my a sub 1, and 29 is a sub 2. And I'm looking for the sum of the first 45 rows. So I'm looking for S sub 45. So my formula, n over 2 times a sub 1 plus a sub n, or the first and the last term. So S sub 45 is going to be 45 over 2. 45 over 2. The first term is 22, but I got to go figure out the last term. So I'm going to go back to my general formula. Okay, and so a sub n in this case, the first term is 22, and they told us it was increasing by 7 every time. So whether you choose to go back and look at these numbers and subtract, or remember from the problem, that's your common difference. And now for a sub 45, I'm just going to go plug in 45 for n, and when I simplify that, I get 330. I'm going to go fill it into my sum formula. And so the sum of the first 45 rows is equal to 7,920 seats. And that's all it is knowing that formula, y'all. And I can't emphasize enough, the best way and the easiest way for you to learn those formulas is to write them down every time you do a problem. Thank you so much for watching, and y'all have a great day.